Hello again, all. Hope you are enjoying a little relaxation. Wanted to post another video here to help you out a little bit with today's work. I know arithmetic and geometric can be a little bit of a challenge when you haven't done it in a while. You kind of forget exactly what things are and how this works. So we're going to go through this. I'm going to do like I did with my previous videos, going to go through a couple of these. Feel free to email me like always if you have follow-up questions. And if I need to, I'll make another video, reply to your email, whatever the case is to help you out. So let's get started here. Throw out there bonus cool points for people to add cool doodles in the corners of their paper. It gives me something fun to look at. I do that for you. I don't know if you've noticed as I've been doing these videos, but I've been adding some fun doodles in the corners. So, bonus cool points for anybody that likes to add fun doodles. Not required, just throwing that out there. I'm going to start off here with number 1. And it's wanting us to state whether it's arithmetic, geometric, or neither. Reminder of those, what this means. So arithmetic is repeated addition. Geometric is repeated multiplication, and neither means it doesn't follow those patterns. It doesn't mean it doesn't have a pattern. It means it's not repeated addition or repeated multiplication. Also keep in mind that repeated addition for arithmetic can be adding a negative number over and over. It can be adding a positive number or adding a negative number. Same thing with geometric. It can be multiplying by a positive or multiplying by a negative number over and over again. So what we're going to do is we're going to go through this and we're going to run a test for number 1. So number 1 says it's 33, 36, 39, 42, and 45. Now I'm going to run the basic test for this, how to do this, so that if you get one that isn't super obvious, you'll know how to do this. Because pretty much the first thing you've got to do with all of these is figure out what the pattern is. Easiest way to do that is to go backwards. And you notice as I'm doing this that I'm saying that we're subtracting going backwards. And the reason is because if we are doing repeated addition going left to right, if we will subtract from there, we will see what we added. So when we subtract these, if we get the same number each time, that will be the number we added. And I know that may seem a little confusing, and I'm going to say that again here. What we're doing is we're doing our inverse. We're working backwards to see what we did in our pattern moving forwards. So what we added each time to get from 33 to 36 and to 39 and 42 and so on that way. And the way we do that is we do our inverse there. We do our opposite to work backwards. So 45 minus 42 gets me 3. 42 minus 39 gets me 3. 39 minus 36 gets me 3. And 36 minus 33 gets me 3. So what I'm doing, going from left to right, going this way, is I am actually adding 3 each time. And I know I'm confusing some of you because I'm talking about addition and subtraction. Subtraction is the test to find what number we're adding each time. Okay? So what we did is we found we got the same number each time. This means this is arithmetic. Okay? If we had gotten a different number each time. So the first time, just as an example, let's say we had subtracted and got 3, and then this one we got 7, and this one we got 11, and this one we got 17. That would mean it's not arithmetic. It doesn't mean it's neither yet, because we would still have to do the geometric test on it, but that means it wouldn't be arithmetic. That's how you know it's not. If it is arithmetic, you will get the same answer repeated over and over again going through there when you do your subtraction test. The way you tell whether or not it's geometric, and I'm going to use this same problem here. I know we've already figured out it's not geometric, but I'm going to use that same problem. So 33, 36, 39, 42, and 45. All right. So what we're going to do is we're going to go backwards again, only this time we're going to do the opposite of geometric, and the opposite of geometric, if you remember geometric, is repeated multiplication. So the opposite of that would be division. So what I'm going to do is I'm going to work backwards there. And I'm going to do 45 divided by 42 gets me, give me as if 1.07143. Oops. 07143. And then I do 42 divided by 39. Gets me 1.07692. And already, the fact that, let's change colors there and make that a little easier. Already, the fact that I'm getting weird, funky decimals is going to kind of set off my spidey sense here and say that something might be wrong. It isn't guaranteed it's wrong, but that might be wrong. But the first time right here, I don't have to do the rest of my tests, because the second one, when I did that, I got a different number than the first one. That means this is not geometric. So, review there. For arithmetic, you are doing the subtraction test, means you're moving backwards, going and subtracting, starting at the far right and working your way left. And for geometric, you are using the division test, starting at the far right and working your way left. If you get the same number all in a row on the subtraction test, it's arithmetic. If you had gotten the same number all the way across on the division test, it would be geometric. If it fails both of those tests, it's neither. Okay? So let me do another problem here and show you what that looks like. All right, so number 2 here, we've got a set of numbers. Just because we got negatives or positives or even a mixture of negatives and positives does not mean it's automatically a neither, but that's when people try to guess on that, and that's not necessarily how that works out. You've got to do your tests if it's not obvious that you know what it is already. Even then, I would recommend it, just because our brain tends to tell us patterns without us necessarily thinking all the way through what that pattern is. Our brains are hardwired to recognize those patterns. But, like I said, it's important to know what those patterns actually mean. So I recommend actually going through that test. And our first test we're going to do is our subtraction test. So again, we're going to work backwards from right to left. We're going to do our subtraction test there. So we do negative 324. Negative 324 minus negative 108. And I get negative 216. And then I'm going to do negative 108 minus negative 36, and I get negative 72. This means automatically it is not arithmetic, because I got a different number first and second time. I got a different number those two times. That means the subtraction test failed. So what I'm going to do, I'm going to set it up again, and I'm going to do the division test. So I've got it set up there. I'm going to work backwards from right to left. And I'm going to do my division test. So I do negative 324 divided by negative 108, and I get positive 3. Then I do negative 108 divided by negative 36, and I get positive 3. And a lot of people are going to be tempted at this point to say, oh, it's 3, I don't have to go any further, but it's a good idea to go ahead and do the rest of them just to make sure. So negative 36 divided by negative 12 gets us positive 3, and negative 12 divided by negative 4 gets us positive 3. So we got 3 each time. This does not mean we are adding 3, because we did the division test. We are now multiplying by 3 each time. That means it passed the division test, which means this is geometric. All right, so number 2 is geometric on there. That's all there is for arithmetic, geometric, or neither. The way you would figure out that it's neither is that you get a different number for those all after the subtraction and the division test. It would fail both of those. All right. So let me set up our next problem down here where we're changing directions, and it's wanting us to find the next 3 terms in each sequence. So let me go ahead and set that up. All right, so for number 5, They are wanting us to find the next three terms in each sequence here. So the first thing we have to do is figure out what pattern we've got going on. Again, the best way to do that is to run your subtraction and your division test. So I'm going to work backwards here. So I'm going to do subtraction test, and I do 120 minus 24, and I get 96. And I do 24 minus 6, and I get 18. Automatically, that's a fail of the subtraction test. So I'm going to go ahead and set up for the division test. So I get that set up there. What I'm going to do is I'm going to work from my right to my left here, and I do 120 divided by 24, and that gets me 5. And then I do 24 divided by 6, which gets me 4. Then I do 6 divided by 2, which gets me 3, and 2 divided by 1, which gets me 2. Now, if you notice, this is neither geometric nor arithmetic. However, it does follow a pattern when we do our division test. So it is still not geometric or arithmetic, but it is following a pattern. And I told you that doesn't necessarily, the neither doesn't mean it doesn't follow a pattern. It just means it's not geometric or arithmetic. So this one, it still failed the division test, because you remember a division test, we would need the same number each time, and we didn't. What we did is we got multiplying by one more number bigger each time. So when I did that, that's times 2, then times 3, then times 4, then times 5, and actually call that multiplying by n plus 1, so number of terms plus one more, which is it's in a way almost a geometric, it's a specialized geometric there. So we are going to continue that pattern since it does follow a pattern. We're going to continue that pattern on. So our next one, we would multiply by 6, then we'll multiply by 7, and then times 8 to get our next three terms. So we are going to start with 120 there, as that was the last one in our last term in our sequence there. So we're going to do 120 times 6, and we get 720. So that would be our next number. So 720. Then we're going to take 720 times 7. We're going to do 5,040. Then we're going to take 5,040 times 8, and we get 40,320. And yes, those seem like big numbers, and they kind of are, but anytime you get geometric, numbers get very large very quickly. So as I said, this is a type of geometric there. You're multiplying by n plus 1, which is one you're not going to see a whole lot, and that is a kind of a specialized one on here, which is why I went over number 5. So if you were struggling with number 5, it's with good reason. But I am going to go over another one here with arithmetic and geometric. So let me go ahead and set up for our next one. Okay, so I'm actually jumping to number 8 here because it's got fractions, and anytime fractions get involved, people start panicking. So know that you don't have to panic. Fractions are our friends. So what we're going to do is we're still going to set up our same thing like we always do. We're working backwards. So I'm going to work backwards here. I'm just going to hit subtraction test, just try to keep things similar here. So we're doing the subtraction test. We work backwards. We do 3 minus 5 halves, and we get 1 half. And we do 5 halves minus 2, and we get 1 half. 2 minus 3 halves, and we get 1 half. And 3 halves minus 1, and we get 1 half. This means each time, since it passed the subtraction test, we get the same number each time, that we're adding 1 half to the number before. This means it is arithmetic. It doesn't care whether it's arithmetic or geometric, except we need that to be able to continue to move on with the pattern. So what I'm going to do is I'm going to take 3 and I'm going to add 1 half, and I'm going to get 7 halves. I'm going to add 1 half to 7 halves, and I get 4. And then I'm going to add 1 half to 4, and I get 9 halves. And generally the next question is, well, could I write it as 3½ and 4½ instead of 7 halves and 9 halves? Well, that is the same thing. So technically, yes. However, if you notice, they give you the pattern in improper fractions already. That means almost certainly anytime you see this in the future, they're going to continue that pattern on. So if you saw it in improper fractions, most likely if you had an answer choice, it would be in improper fractions. So I really do want to prepare you for this, just because, right now it's looking like we don't have EOCs. I've not heard official statement from the school saying that yet, but that's certainly the recommendation from the state superintendent. Even if that's the case, you still have math next year and the year after that. So I'm still trying to prepare you for that. So even though we don't have EOC stuff, that EOC is designed to help prepare you for the next year. So I'm still trying to prepare you best I can. So your best interest would be to put it in an improper fraction. The good news is if you're using your calculator, it does that for you already. If you're using Desmos, it does that for you already. Do keep in mind you have Desmos available to you. Don't forget that as an online calculator. I know some of you are probably just using Google Calculator, but it has difficulty doing some things. Remember, Desmos will do pretty much everything your calculator will do, so don't forget that. All right, let's go to our next one that we're looking for the 10th term in each sequence. Okay, so for this one, finding the nth term in a sequence, we've really got two options. Being only the 10th term, just following our pattern until we get to number 10 is a valid option. That's not that many terms to find. If it wanted us to find, say, the 100th term or the 25th term or any of those that would be kind of a largish number, you would want to use your formula for that. I'm going to show you both ways in case you want to do whichever one, but since this is review and we're trying to get you to where you know how to do it either way, I want you to know either way. Even if you had a great big one, you could do it by repeating the pattern. You just with that many times repeating it, you're more likely to make a mistake. Either way, the first step for this is the same. We're going to do our subtraction and division test to figure out do we have arithmetic or geometric and what our common ratio or difference is. That's what we're adding or multiplying by each time. So we do 64 divided by negative 32, we get negative 2. Negative 32 divided by 16, we get negative 2. 16 divided by negative 8, we get negative 2. And negative 8 divided by 4, we get negative 2. So on this one, it is division, and I did division first, mainly just to try to keep this video a little shorter because it is, I recognized it as a geometric. If you did subtraction test first, that's fine. What would happen? You do 64 minus negative 32, and you get positive 96. And then you're going to do negative 32 minus 16, and you're going to get negative 48. So right there is automatically going to show you big difference in numbers there. It's not the same, so it's not arithmetic. What we have here is a geometric sequence where we are multiplying by negative 2 over and over and over again. So we have 5 terms. What we can do is continue that and know that this is 1, 2, 3, 4, and 5. And so to find 6, 7, 8, 9, and 10, it only wants this last one, this 10th one. But we've got to find those other ones in the pattern to be able to find that 10th one. So that is one way is I can just continue to multiply this on. So what I'm going to do is 64 times negative 2, and that gets me negative 128. And then I'm going to do negative 128 times negative 2. That gets me positive 256. Then I'm going to do positive 256 times negative 2, and that gets me negative 512. And I'm going to multiply that by negative 2, and that gets me positive 1024. And I'm going to multiply that by negative 2, and I get negative 2020. Said that wrong. 2048. All right, so that is one way to do it, is just to multiply it out. That doesn't take that long, and like I said, for many of you that may be easier simply because you don't have to try to remember a formula. Now, you do have more chance for mistake, but it's not that bad for a short number like this. The really big numbers, it's a lot more difficult to keep everything straight in what term you're on. The other option is to be able to do your geometric formula, and that is a sub n equals a sub 1 times r to the n minus 1. And you may be going, I don't remember what any of that is, and that's okay. I'm getting ready to tell you what that is. So what you have here, a sub n, that first one there, that's the nth term, and that's actually your answer. So when you're going through and finding, in this case, it's going to be negative 2048 when I'm done. That'll go over here. That's going to be the answer. I haven't found that yet, but that's where it'll be. A sub 1 is my first term. So that very first number they gave me, that positive 4, is what's going to go into that spot where the first term goes. The common ratio is that number I multiply by over and over again. That's what I got from my division test back here. When I was working backwards and dividing everything and I got negative 2 as that number that repeats over and over again, that's my common ratio. With arithmetic sequences, it's called a common difference, and that's the number you add by, but we'll get to that here in a little bit. N is the number of the term you're looking for. So in this case, we're looking for the 10th term. N will be 10 up here. So I'm actually going to clear some of this out of the way so we've got some room to work, and I'm actually going to set this up for you. Okay, so we got a sub n, that's what we're trying to find. And I'm going to go ahead and replace that with a 10 because that's the number we're looking for, and we said there was an n, that's the number we're looking for. A sub 1, that's the first term, that was a 4, times r, that's our common ratio, which is negative 2, raised to the n minus 1. So again, n is 10 minus 1. And I could go ahead and simplify that and have to the 9th power. So I'm going to go ahead and simplify this a little bit. A sub 10, that's the term we're looking for. 4 times negative 2 raised to the 9th power. Now all I got to do is type this part right here in my calculator. All I got to do is type that little expression in. And what I get is a sub 10 equals negative 2048. So that's the fast way. If you can remember your sequences, all you got to do is plug everything in, type it in your calculator, it gives you the answer, and you don't have to multiply over and over and over and over again. As I said, that's the fast way, but depending on your memory and your familiarity and ease and all, it may be easier to do the pattern out. Let's do one that's arithmetic real quick so that we know how to do that. Same kind of thing's going to apply, just a different formula. Okay, so I'm doing this one because it is an arithmetic, and if you're not sure, you could still do your subtraction and division tests. This one's going to pass the subtraction test, so when I subtract that, I'm going to get 5. Subtract, I get 5. 32 minus 27, I get 5. 27 minus 22, I get 5. So that's going to pass the subtraction test, and because I was subtracting, that means I'm adding these, and I know that, again, that seems backwards, but that's your test to see what you're adding over and over again. So this gives me, again, the first 5 terms, and I'm looking for the 10th term. So again, I could just take, starting at that 5th term, and go ahead and continue out and find 6, 7, 8, 9, and 10. And do that by adding my common difference that I found. That's this 5 right here. Remember, with geometric, I just said it was called a common ratio. With arithmetic, it's called a common difference. That's this number we're adding over and over again. And I could just continue adding, and I get 42 plus 5 gives me 47. 47 plus 5 gives me 52. 52 plus 5 gives me 57. 57 plus 5 gets me 62. And 62 plus 5 gets me 67. So that would be my 10th term. That'd be my answer. But as I said, that's the long way, and that's the way that you're more likely to make mistakes. So what I'm going to do is I'm going to show you the arithmetic sequence just like I did with the geometric sequence, because that is the fast way, provided it is an arithmetic or geometric pattern. Do keep in mind they could potentially have you follow these patterns here and it not be one of those, and you would have to continue the pattern, whatever they're doing, over and over again, not necessarily just following the strict pattern we've got here. Okay, so keep that in mind. That's a possibility. All right, so similar to geometric sequences, it's very similar equation here, and I'll actually box that in a little bit, make it a little more easier to see. There you go, that's more better. Make that a little easier to see there. So we've got a sub n, same thing it was before, it's the nth term, that's our answer. That's on this one going to be 67, but we're not there yet. A sub 1, which is your first term, and this one they gave you 22 as your first term. So that's going to be what goes there. Your common difference, d, which is in the equation here, that is going to be the number we found with our subtraction test. Remember, subtraction test finds common difference, that's the d. Division test finds common ratio, that's your r. and then n is the number of the term you're looking for, just like it was. So really the only thing we have different, we've got it in a different order, but D is the only new thing between the last formula and this one. So I'm going to go ahead and set this one up. So A sub n is the one we're looking for, and I'm going to go ahead and replace that n with a 10, just like I did before, because we're looking for the 10th term. And then I got A sub 1, which is my first term. We said that's 22. It's the first one they gave us. Plus n minus 1. N is the 10th term, so 10 minus 1 times D, which is my common difference. So that's 5. That's the number I found up here when I did my subtraction test. Again, I can go ahead and simplify that a little bit. Do A sub 10. Yes, you could do this ahead of time, but I'm showing you the whole thing so that we don't have any magic numbers. 10 minus 1 is 9. And then it's a matter of typing this right here into your calculator, and it gives you the answer, which is 67. A sub 10 equals 67. Notice we got the same answer either way. This is definitely faster if you can set up that equation, because all you got to do is set it in the equation and type one thing in your calculator, ta-da, you're done. Less likely to make errors, but as I said, it just depends on which one's easier for you. For these small numbers, it may be easier for you to complete the pattern. Now, you are going to need those equations here, what I did here, for your next two sections. And I know this video is kind of running long. Please feel free to skip around if you haven't been already. Use what you need. You don't have to necessarily have all of it, but I'm trying to keep it as short as I can. You're going to need those for the next two sections here. I'm going to give you an example and set it up. Now, they are nice with these. They tell you these are all common differences, so you're going to be using arithmetic, and these are common ratios, so you're going to be using geometric. So they do separate it out. I'm going to do one of each of those, and like I said, try to keep this from being ridiculously long. Okay, again, so they're nice here. I'm doing number 13. They told us it's a common difference, so we only need to do the subtraction test. And when I subtract, the number I get over and over and over again going through that is 200. What that means is that I'm adding 200 each time. That's going to be my common difference. So one of my answers is going to be D equals 200, because that's the common difference. Then it wants the explicit formula. That wants you to plug it into that formula we had just a moment ago. So that's A sub n equals A sub 1 plus n minus 1 times D. So this wants you to plug everything in. So A sub n, because I don't know what term I'm looking for yet. A sub 1, that's my first term, which they gave us up here. That's 23. So 23 plus n minus 1, again, I don't know what term it is, so I'm just going to leave it there, times D, which is 200. That's my common difference. And that's going to be your answer for that. So your two answers are D equals 200, and then this formula down here. And that's going to be all of them. All you're doing is going to be plugging in the first term, and you're going to be plugging in the common difference into that formula. The formula is going to look exactly the same for all of those. The only two numbers that will change will be the 23 right there. It's the first term. So it'll be whatever the first term they've got in their sequence there is. And then D, which is the common difference, whatever you get from your subtraction test when you do that. So that's all arithmetic is. Let me do a geometric one. It's very similar. Okay, again, they're nice, and they tell us this is a common ratio, so we only need to do the division test on this one, this being number 17 here. Only need to do the division test, and when I do that, what I'm going to do is I wind up getting -3 each time as I work backwards. -27 divided by 9 is -3, 9 divided by -3 is -3, and -3 divided by 1 is -3. This is my common ratio. That means I am multiplying by -3 over and over again. So one of my answers, because it asked me to find the common ratio, is R equals -3. That's one of my answers. So the next thing it wants is the explicit formula, which is that formula I had before. So again, very similar to what we had for arithmetic. A sub n equals A sub 1, in this case, times R raised to the n minus 1. So just like I did with arithmetic, all I'm doing is replacing A sub 1, and in this case, my common ratio instead of my common difference. So I'm going to plug those in. So A sub n, I don't know what that is, so I'm going to leave it just like it is. A sub 1 is my first term, which they give us up here. In this case, it's 1. So 1, parentheses, R, that's my common ratio. That was what I got from my division test. In this case, -3, make sure it is in parentheses, all raised to the n minus 1, because I don't know what n is yet. So this is my answer right here, just like that. And all of these are going to look exactly the same. The only thing that's going to change is I'm going to replace that first term with whatever the first term in the sequence is, which it actually looks like 2 more of those is just still the number 1, so that'll be the same. And then right here, that common ratio, and that's whatever I get from my division test when I work backwards there. Okay? I know this one started to get a little lengthy here, but I know sequences can be a little bit of a challenge for people sometimes, so I tried to go in a little more depth with it. If you're still getting stuck, please don't hesitate to reach out to me. I'm here. I've been pretty quick about responding to those of you that have emailed me already, and I am trying to stay on top of that. If it is taking me a second to get back, it's not that I'm ignoring you or I don't see it. It's probably because I'm answering other people's questions too. But do be patient with me. I'll get back to you within minutes. Okay? Alrighty. I look forward to talking to you guys again tomorrow. Have fun.